a little bit of time on other considerations with government intervention, and I'm going to do a kind of a little bit of flashback, and then the bigger thing is you've got some homework for Friday that I'd like you to just knock out. At the end of the chapter, this is actually the way I did problems, and we'll continue. I was planning to do it, but now I've kind of figured out which ones I want to do because of the learning curve stuff. At the end of chapter 3 is where we're going to spend our focus and do numbers 7, 10, 11. So chapter 3, 7, 10, 11, 15, and 19.
Are these the problems?
These are the problems. So this is also going to give you practice for the short answer type of problems that we'll do in class instead of the multiple choice variety like we have on the system, the online system. All of the problems I assigned you have the answers in the back. So what I recommend is that you give a good faith effort on your own, but then go back and check if you're on the right track so you don't go down the wrong track too far. Go ahead and flip through. I mean, this is really for you guys to learn the problems, and I always felt it was important when I was learning stuff like this to be able to, it was helpful to check on how I was doing right away. So at the back of your book, whether it's your ebook or if you guys got the full book, so the ebook's there too, you just go back to the chapters, it's going to be an exact replica of this. The questions all have a little asterisk by them that I assigned. All of these are the asterisk problems, and the answer, there's solutions in the back. So what I'd like to do is have you, these are the types of things where you're going to want to handwrite it, not put them into the computer, or it's not very easy. I guess it's getting easier and easier as technology evolves. But it'd be nice to have you upload those to Blackboard, but still bring them into class. So I'd like to experiment with that. How many of you have done the scanning using the computer, the school's printers? So you guys know you can go and make copies of stuff, right, using your code. I'm not sure, but I'm pretty sure that this can be done by students. I do it all the time. So if you put your handwritten notes into the copier and press scanner, you can send an email of it to yourself, and it'll create a PDF of that file. So then you just email it to yourself, boom, you've got a digital copy, and then you upload it to Blackboard. And this will be handy to be able to do, so I'd like to have you do it this way. Let's see if we have issues. Maybe I even need to go to IT to make sure that it's set up. But Ottawa University is moving more towards archiving your material into Blackboard because of accreditation issues that we always face, to have proof that you guys are actually doing something in class. And so they want that archived somewhere. And so that's the way that we're moving towards doing that for accreditation purposes.
Is that in the library?
I think so. I think any of the copiers, like the Adaway Center has one. Wherever you guys can make copies for yourself, I think you can use the scanning function. But I'm not sure, so this is a bit of an experiment. So go out there and do it and see what you find out, and let's talk about it on Friday. But on Friday, bring your handwritten answers to class so that we can review them. That's my main objective. All right, so quick review on some of the types of government interventions. Just to kind of have something in your notes to refer back to. We spent time doing consumer and producer surplus, and we spent time doing a tax the other day. I don't think I did completely a subsidy, so let's just start with a subsidy. Just the general picture. So if you guys draw a home base is our free market starting place. And with a subsidy, you can give money to the consumer, or you can give the money to the producer. When you do that with an equation, you take the inverse supply or the inverse demand and you add the amount of the per unit subsidy onto it, similar to what we did with the tax the other day. And how that would shake down then is the supply curve or demand curve, depending on what you're adding it to. So if you're giving the consumers the money, kind of like you guys with education, we give you grant money, right? That increases your demand, if you want to think of it that way. The demand curve with the subsidy ends up looking like this functionally, in functional form, because you've added that vertical distance to it. So this vertical distance here is the amount of the subsidy per unit. The quantity that will be traded in the marketplace, QS, the quantity after the subsidy, is where the demand with the subsidy, kind of the fake demand curve, like I like to call it, and the real supply curve intersect, giving you PP, the price that the producer gets. But the consumer doesn't pay that much because the government's paying the subsidy, so the consumer ends up paying where the real demand curve is, and the quantity after the subsidy, PC. So the consumer pays a lower price than what the producer receives. Just the opposite of a tax. So this is really the same graph. Remember the tax, of course, is over here. We did that last time. This area here is the amount of tax revenue, or the amount of expenditure. So that is government spending or government expenditure on the subsidy program. For consumer and producer surplus, remember that grows because consumers are consuming QS, and so that gives them this big triangle, the difference between what they're willing to pay and what they actually pay, which is a little weird. Notice we're not going up to this one because that's the fake one, right? So they're willing to pay this amount, they actually pay this amount. So there's the consumer surplus. Producers are receiving this price and selling that quantity. So you go back to the real supply curve to determine the producer surplus area, and then you've got the government to take into account possibly too. But if the question just asks for the change in producer surplus, then you just deal with producers. If it asks for what is the new consumer surplus, then you got to calculate that. So be careful on the wording of the question and what they're asking for. Okay, questions on that?
So if it was the new producer surplus, it would be that dotted triangle, right?
The new producer surplus, we're selling QS. The minimum amount we must get is the marginal cost of each additional unit. We're actually getting PP.
Okay, so that thing's different. And then consumers.
Consumers here.
Okay.
They overlap, so it's kind of weird with that one. So you got to go back to the original definition of consumer and producer surplus, the difference between what a consumer is willing to pay and what they actually pay. And for producers, the difference between the price they actually get and the minimum amount they must get for each additional unit. Those are our basic definitions of producer and consumer surplus. Okay, price floor, price ceiling. So price controls in general. Draw a home base. A price floor, if it's effective, is set above the equilibrium price. So there's your floor price. Set by law, it's the minimum. If we're talking minimum wage, maybe the market would clear at $5, but minimum wage is at $7.15 or something, right? So the floor price is set higher than the market clearing equilibrium price, free from intervention. Producers are going to produce this amount. That's the quantity supplied. But consumers are only going to buy QD, the quantity demanded. So from an equation standpoint, if the price floor is $7.15 an hour, if we enter that into our demand equation and solve for that quantity, that's how we'd start to put the puzzle pieces together, right? Now the problem here is that if we go back to producer and consumer surplus, the producers are not selling what they have. This creates a surplus. And if it creates a surplus, that's where we got into the weird producer surplus area, because we're only going to sell what's being demanded. And so the quantity exchanged is actually the short side of the market. And so the producer surplus area was this weird area here. Some producers are going to get the floor price. Some producers aren't going to sell their product. And so the producer surplus area ended up being this weird area. Not a triangle is kind of the thing I wanted to bring back to your attention. What would what? The consumer surplus right here.
Oh, just that small triangle?
Yep. Because they're going to be paying the floor price and only buying this amount.
And would that smaller triangle to the right of how you demanded be the deadweight loss?
Yep. So deadweight, well, yes, this is deadweight loss. And so the deadweight loss is a comparison of free market versus the implementation of the policy. So free market's here. If that was our starting place, then that created this deadweight loss triangle here.
So the deadweight loss is created by not using the free market?
Yes, if we're using it in comparison to that. If that's our status quo, our starting place. So with the price ceiling, our intent of the policy is to try to help out the consumers. So rents are too high, so let's put a cap on rents. A two-bedroom apartment would normally sell for $800. We think that's too high, so let's put a price ceiling, PC, or the ceiling price here at $600. The ceiling causes a shortage. The quantity supplied now is less than the quantity demanded. So some consumers go without an apartment, at least that type of apartment, quality apartment. And now it's consumers that have kind of a weird non-triangular amount because the short side of the market wins again. In terms of what gets exchanged, I don't think anybody really wins, I guess might be a stretch. But the consumer surplus changes to this trapezoidal area. The difference between what they're willing to pay and what they actually pay, the ceiling price for each unit that they consume, but they don't consume out here, they consume here. Yes. So the producer is now down here. Yep.
Is it like basically anytime the government sets a price or does a subsidy or something like that, there's going to be deadweight loss?
Yes, except in extreme cases where the demand curve is perfectly inelastic. So if the demand for cocaine, if this is the cocaine market, and cocaine demand looks like this, right? Then that tax is going to be successfully passed over to the cocaine addicts. without losing any quantity compared to the free market. Okay?
And then I have a question about the subsidy. Was that triangle to the right be the deadweight loss then?
Yes. This ends up being the deadweight loss. And that stuff you can go back and kind of look at the change in social welfare. If you look at the change in consumer surplus plus the change in producer surplus compared to the free market, and it can be compared to another circumstance. I'm using the free market as our kind of status quo starting place as a comparison, but it doesn't have to be. Change in government revenue. If the government collects money from a tax, we'd want to take that into account. That ends up being the change in social welfare. If you add up all of these changes, this represents the world in our market. We've got people who buy stuff, people who sell stuff, and then the government collectively doing things for everybody. That takes into account all the pieces of our market system puzzle. Which I don't have my puzzle piece in here. I like using that as a quick reference. I'm going to get that back in there. So this ends up being the deadweight loss piece usually. Unless it's an extreme case and this ends up being zero.
You think that change in social welfare
Is deadweight loss. But if that change in social welfare is zero, which is what the case was with the cocaine deal,
right?
then the change in social welfare is zero, there is no deadweight loss.
So in that sense, demand is inelastic, correct?
That's what?
When demand is perfectly inelastic?
Yeah. But that's not the only case. How else can it happen? Supply is inelastic. So supply is inelastic, then the whole tax gets passed off to the drug dealer. And again, there's no change. But that's not the only case. Well, maybe it is the only case. If we do, I was going to say we can have a combination of both. The tax burden can be changed, but there'd still be deadweight loss if we have perfectly elastic demand. So if we do this, then the producer pays all of the tax, but there's actually a pretty good sized deadweight loss. So that's when we talked about the tax burden, is that formula that we did with the relative elasticities. That determines who pays the burden of the tax.
So with a ceiling, the consumer has a larger surplus than the producer and vice versa?
Well, they lost some too. It depends on this area versus this area. The way I've got the graph shown, this one looks bigger than this one, but that wouldn't necessarily have to be the case. Whether the consumer overall is made better off. Because they lost, remember, without the ceiling in play, they had this little chunk here was their welfare. So they gained this and they lost that. Yeah, that's what you do. Yeah, as long as you had all the numbers and information. Yeah, find the choke price and all that stuff, and you have it. Okay, quota. Instead of messing around with prices like we do with subsidies, taxes, and price ceilings, what if we dink around with the quantities? So we go back to our free market. Quota. Now imagine the government's just stepping in and saying, man, we can only do half as much as what we were doing. So we're going to put a quota, let's just call it QQ, yeah. That'll work. So the quota right here, and we're not going to allow anything to be traded beyond this point. Now, if you think about it, the government is, in some ways, helping the producer act like a monopoly, right? We're restricting the quantity, allowing prices to go up. is one way to think about it. So if the equilibrium price, or if the equilibrium quantity is out here and we restrict the quantity, prices are going to gravitate up. Where are they going to stop? Well, they're going to stop at the highest price people are willing and able to pay, which is given by the demand curve. And so this will be the price with the quota in place. Let's call it PQ. And then we just go back and analyze the effects of that. Consumers are back down to here. Right? They're paying PQ, and they're only buying QQ. And producers are getting PQ, and the minimum amount they must get, so they're back to this trapezoidal area, which matches this one, by the way, in concept. Still have a deadweight loss. Government's not collecting any money to offset it.
But there's going to be other effects from the quota. Necessarily might not all get passed on to the consumer when prices increase, right? I mean, substitutes might come into play.
Yeah, the substitutes are right here, though. I mean, there could be possibly more, if we're thinking more dynamically about it and allowing time to go on, then yeah, maybe some people would develop new substitutes. And as new goods come up, then that type of argument would lead to demand becoming more elastic and possibly bring the quota price down in a similar way. But if the quota still stays in place, then that's all that would happen with more substitutes coming in. But yeah, it's possible that would be a more secondary effect with multiple time frames. All right, so that's the quota deal. So then you can maybe hopefully your brain's starting to say, well, how would that work with equations? Well, that's what you're going to do with your homework. But we start to shove in this Q into the formula, and we can solve for this, or we could solve for this, right? We shove this into the demand function, and we could solve for this. So you start to put the pieces together. I think it's helpful to look at it graphically and then kind of go back to the equation and start saying, oh yeah, this is what I need to do. Okay, anything else there? So that's at least a quick rundown. Judging by what I saw on the learning curve, I thought it was helpful to maybe, you guys are all at about 50%, almost across the board on that chapter. So 50 to 55, you were in the 50s. And in the other chapter, you were in like the 80s. So I'm kind of liking this learning curve that I can kind of see where we might need to have a little extra talk. Okay.
This was based on the chapter 3 learning curve.
This is chapter 3 stuff, yes. Yep.
When is the chapter 4?
Chapter 4, I was going to have due for Sunday, which we're going to work on more today now. All right, so that's a pretty good segue. So you guys got the homework for chapter 3. We're going to got some problems to do now. Let's pull out your sheets, and we started in on one, didn't we? We started in on the Braden budget constraint. I think we just talked generically about it, right? 4.3. We did 4.1 on Monday.
4.1 on Monday and 4.3 on Friday.
No, we're doing 4.3 right now.
Oh, so you did.
Friday we just did general, the 4 axioms of choice. You got that email, right? Because that I had on, okay. All right, so let's go ahead and try tackling 4.1. Braden's got $20 per week that he can spend on video game rentals priced at $5 per game and candy bars priced at $1. Write an equation for Braden's budget constraint. Draw it on a graph that has video game rentals on the horizontal axis. Be sure to show both the intercepts. Okay, go. Okay, pause. Now that your brain hopefully started to get engaged, what are you doing? Budget constraint. Like, okay, so you're going back to that formula that we did, okay? And did you plug in, what are you plugging in?
The price of the video game.
Okay, so we got the prices, we got the income. So the consumer's problem in general is to maximize utility, maximize total utility subject to a budget constraint. That's composed of prices and incomes. So budget constraints has income and the prices of goods. In this case, we've got the price of video games and the price of candy and some income. The utility function we don't have, but we know that utility is some function of the quantity of video games and the quantity of candy. But we haven't been given that function. I'm just telling you generically, right? That's this whole problem. How do I make myself as happy as possible, optimally choosing the quantity of video games and the quantity of candy that would make me happy, subject to the fact that I've got 20 bucks and video games are $5 and candy's $1. That's the big problem that we're trying to solve, ultimately. This particular problem focuses on the budget constraint. Write an equation for the budget constraint and draw it on the graph as part A. Yes? Yes, only because they told you which one. So video game on the horizontal axis. Otherwise, in general, we could work with it either way. Okay, good. What's your budget constraint? What's this?
Yeah,
What's this part?
it's I'm done with that.
Okay. We're drawing the budget constraint. So you were getting into supply and demand. This problem's not doing supply and demand at all. So for the budget constraint, we're going to have the quantity of, because they told us here, the quantity of video games on the horizontal axis. Is that what you did?
Yeah.
Okay, game rentals. And then the quantity of candy on the horizontal. And then erase your supply and demand.
Is that an equation?
Don't use X's and Y's. Use exactly what we have. So I would suggest using the QVs and the PC and the QCs for the income constraint.
Okay.
And you were gone on Monday. We kind of put it up generically last time, but so we're trying to spend all of our money. I see some of you put what we did on Monday. Income was equal to the amount of money I spend on good X plus the amount of money I spend on good Y. So we had X-rays and yo-yos. So that's your budget constraint. Technically, I can't spend more than my income's going to be greater than or equal to the spending I do on the two goods, technically, right? But if it's equal, then that means we're spending all our money. We don't get any utility from unused income, so that's why we put that equal sign there. It's just we're going to spend whatever we got, kind of the American way, unfortunately. Maybe it's due to principles classes showing that it's better. We're better off if we spend all our money, but it's not true. As we get into more sophisticated models, we need to think about the value of savings and future consumption. But that's the thing we do at first. So what does this sucker look like? What's the intercept. 20. Why?
They spent all their money on candy bars and they could get 20.
Okay, good. It's not the choke price. Did I hear choke price? I didn't know if you're kidding or not, but don't use that word. We're going to have that word specially for what?
Wouldn't it be a choke something?
No, not in this case.
Choke
Well, I mean, we could tell a story, but let's reserve. I mean, we could say it in layman's terms. Well, it's kind of like the choke, and it is. We're choking off all consumption of video games, right? Beyond that place. So we could tell a story, but don't tell yourself that story because you want to keep choke price sacred to what? Where did we use choke price?
The highest number of consumers will buy goods.
Yes, the highest price consumers will pay. So when we had the demand curve and we're looking at the quantity of video games and the price of video games, the choke price was the price that choked off everything, the highest price consumers were willing to pay. We also had a choke price for supply. It was the lowest price that would cause the producer to bring the first unit to market. So that was our vertical intercepts for the demand function and the supply function. And the inverse, technically in that graph, the inverse demand and inverse supply. All right, so 20, I'm with you. And what's down here? 4. 1, 2, 3, 4. And what does it look like in between? Straight line. So that is our budget constraint. And lastly, what's the functional form of this straight line and slope intercept form? C, or I'm using QC. I'm okay with using C. I like to, the reason I've gone back and forth, because I've used C too, and you guys aren't going to lose any credit if you do that, but I kind of like putting the Q there as a reminder that it's the quantity, to kind of keep reinforcing each time you look at it that that's the quantity of candy instead of the price or whatever. But kind of your option on that. So, and depending on a problem, maybe you have to be flexible going back and forth. But so quantity of candy is equal to -5 QB. Okay, quantity video game rental. Did you have? Okay, is that what they used here? They used R. Sorry. Try to stay consistent. All right, so rental, and plus 20. All right. Generically, did you guys solve for it generically? Because you should really know that one too. So generically, instead of substituting in the numbers, you should also know this generic one. What is the 5? Price of rental divided by price of candy, the other thing. Yes. So with this particular problem, since this was a 1, that was harder to pull out. But that, if you solve out the real budget constraint, if you solve this for QY, that's the price ratio. That is super important because that's going to come into play here in a little bit. So this is the price of rentals over the price of candy times QR plus, what's the 20? Income divided by price of candy. So this one is just as important, if not more important, to know. Keeping everything totally general. They all tell a nice story with each other. Okay, yeah, that makes sense. If I blow all my money on candy, how many can I have? I can have 20. So it all tells the right story, but you should be able to go back and forth. Questions on that? All right, so what about the interpretation of the price ratio? Price ratio, or the relative price, is a super important concept in Econ. What is the significance of that? the slope of the budget constraint and more. What is the significance of the slope and therefore the price ratio? What is it telling us?
It's the relationship between one and the other, what we have to give up or not give.
Yeah, and it's the actual quantities we have to give up, right? It's not dollars, which this one is a little more tricky in a sense, but because of the one thing. But work through the math altogether in a different way. Think of it a little strangely. If you take the price of a rental at $5 for every quantity of rentals, divided by $1 for every quantity of candy, that gives me 5 divided by 1 is 5, dollars per quantity of rentals times quantity of candy divided by dollars. The dollars cancel out, and I've got 5 units of candy for every rental. It converted the dollars into the actual trades that are allowed in the marketplace. The market allows you to always trade 5 candies for 1 rental. That's what you're able to do in the market. How many of you heard of the saying, willing and able buyer? It's kind of a thing that you may have heard, kind of a cliche. Well, this is where it comes from. I have a willing and able buyer. So the budget constraint tells you your ability to make a purchase via the income that you make, maybe, is part of your ability to make the purchase. And then you've got the willingness comes from the utility function, which we worked on last time. And the solution to this problem is we're going to need what that person's preferences look like. If they're kind of a candy hater because they have some issues, that person's indifference map, their preferences might look like this. So that when they go to the market, they optimally solve their problem by having lots of rentals and a little bit of candy. But if they're a sweet tooth like my wife, and not so much hung up on video games, their preference map might look like this. Where they're like, I don't really like rentals. So these are 2 different human beings, bear in mind. And my wife is solving her consumer problem by having very few rentals and lots of candy. Right? So these are different human beings. What do they look like? That's dependent upon their preferences, which is captured by the indifference curves that we talked about last time. All right, so we'll get to the full optimization process on Friday. So hit your, what did I assign for the homework problems for Friday?